Hello, this is BBackes coming to you from sunny Arizona. My presentation is on cognitive work analysis and ecological interface design as it relates to the area of human-computer interaction. My interest in this framework comes from trying to understand how ecological design helps expedite the cognitive process. Additionally, I'm also interested in the idea of identifying limitations as part of an early analytical process in order to accommodate and integrate constraints in a final interface design. The cognitive work analysis was developed to create a working model that can be applied to real work situations. The cognitive work analysis directly impacts human-computer interaction by providing a platform for creating processes to handle unexpected situations in complex work environments. There are many cases where workers are required to take in a large volume of information quickly, comprehend the information in order to act on the information. An example of this type of work environment would be a pilot flying an aircraft. Pilots need to operate an aircraft, keep a parallel line to the ground, watch for other aircraft, and adjust as all of these variables change throughout a flight. A side effect from cognitive work analysis is ecological interface design. In contrast to other design methodologies, ecological interface design focuses on the environment as opposed to the task or the operator. A cognitive work analysis consists of 5 phases. The first phase is the work domain. During this initial phase, the physical environment is reviewed, the production process is assessed, the task structure is evaluated. This first phase allows for any constraints or limitations to be revealed. This is important as the limitations will need to be accommodated as part of the final solution. The second phase is the control task analysis. The goal for this phase is to identify what tasks are needed to be done in order to execute a process. Information from this phase incorporated into a design helps operators recognize what needs to be done when monitoring a system. The third phase of analysis is strategy. This analysis provides information to create a process for any operator to complete a control task. The fourth phase is the social organizational analysis. In this phase, responsibility for control tasks is allocated to operators based on the workplace personnel and structure. This phase also divides tasks between human operators and computer-based systems based on purpose. The last phase is the worker competency analysis. This final evaluation identifies cognitive and perceptual capabilities needed to effectively execute control tasks. The goal with this phase is to acquire information for the purpose of creating a system design that minimizes cognitive processing and expedites comprehension. The phased analytical framework provides a way to efficiently analyze the situation to glean information for creating and executing a successful system design. Drawing on our example of a pilot flying an aircraft, a cognitive work analysis can provide data to help designers know where to place flight information displays, what content to include in a display, and how best to structure the information so that it lessens the time and the effort needed to understand and execute tasks while ensuring any limitations discovered in the first phase are easily understood by the pilot. Operator performance can also improve. With less effort needed to figure out constraints, an operator can focus on adjusting their performance to adapt to unexpected change in their work domain. Ecological interface design is another benefit from this process. This design approach is based on the work environment rather than the operator. The goal of ecological interface design is to structure the information based on the operator's environment. By doing this, less cognitive processing time is needed since the operator is already familiar with their environment. This design strategy allows operators to quickly perceive irregularities in order to adapt to unexpected change. This design strategy provides information in context to support comprehension. When information is meaningful, an operator can process it automatically when viewed from a visual display. Information presented from an ecological point of view provides a way to show multiple information sets related to a changing situation. As a pilot flies an aircraft, it is more effective to show information about airspeed, altitude, heading, and course deviation in one display so the pilot can review these environmental elements and make changes accordingly. An informational display based on an ecological interface design allows the pilot to complete the tasks in any order needed in order to best adapt to change while flying an aircraft. Ecological interface design provides a function-based approach for displaying information in situations where adapting to change is needed for success. A cognitive work analysis provides empirical data to help designers know what information to include, what information should be grouped, and when to show and where to show the information in a display. An ecological interface design supports operator adaptation by showing work domain constraints as part of the design. By doing this, an operator does not need to find the existing limitations, and this tactic allows them to react faster to a changing environment. Affordances are then placed in relation to any limitations in context to the environment. An example of this would be controlling the pitch of an aircraft. The proximity of the pitch information, including the limitations for the pitch that the pilot has available, is located relative to the yoke, allows for a seamless experience as the pilot takes in the information and then reacts as needed to adjust the pitch of the aircraft. Information is functionally grouped to provide an operator access to all situational information when needed. Lastly, this design strategy aims to provide answers before there are questions. This tactic removes the need for deciphering information and recalling previous information when trying to adapt to changes in a work environment. In summary, a cognitive work analysis provides a way to discover constraints that may impede capabilities for handling change in a complex work domain. The goal of ecological interface design is to provide functional information and visual displays for executing controlled tasks. From the perspective of an answer-based informational structure, multiple information sets are displayed in proximity, allowing the operator to quickly take in large amounts of data and react as needed. Aligned with the operator's environment, information in an ecological interface design is placed relative to the work domain environment. Information from a cognitive analysis is used to shape an ecological interface design. Given the ability to scale this framework, this analytical tactic is best used for creating interfaces in complex workplaces where operators have minimal time to comprehend information before adapting to a changing situation. Thank you for listening.